TV. We are at HIMSS 2012 in Las Vegas, and today I am with Dr. Richard Wolniewicz from 3M. He is the Divisional Scientist for Natural Language Processing. Thank you for being with us today.
My pleasure. Thank you for having me.
Can you spend a little bit of time and tell us about what natural language processing is?
So natural language processing is the processing of human written text or language by computers. So we're all very familiar with natural language processing in, say, email spam detection. So I'm old enough to remember the days where I had to go into the email system and say, oh, this email is spam, so block this sender, and teach my email system who was valid, who was not. Nowadays, using Gmail, we don't even think about it, right? It's all hidden, it does a great job, but it processes the text and understands which is content that's legitimate, which is content that's not. We also see natural language processing in Google when we have a link that says translate this page. That's a different kind of natural language processing. It's doing machine translation, but it's again using the same technologies. IBM Watson was a question answering system. We all saw IBM Watson perform so well on Jeopardy. And you know, in the healthcare space, autocoding is another application of natural language processing, as is speech recognition. So we all see Dragon, naturally speaking, from Nuance is a really good speech recognition algorithm that's widely used in healthcare.
So given the different kinds of NLP, where does autocoding fit?
So autocoding is a lot like email spam detection. You're trying to classify a document in email as spam or not spam, in autocoding as having or not having this code, having or not having that code. Of course, it's much more complicated with ICD-9 having tens of thousands of codes, not just one
Correct.
flag, spam or not spam. ICD-10 has hundreds of thousands of codes. So much, much more complicated, but it's that kind of classification system. And in fact, a lot of our lessons from email spam detection apply quite well in healthcare to what it's going to look like with natural language processing. It also sort of illustrates that healthcare is 10 to 15 years behind other industries in adopting natural language processing. A lot of the questions we get these days are questions that other industries answered about NLP, but we're addressing for the first time in healthcare. But much like email, I expect that we will see natural language processing disappear into the background as it becomes much more and more effective.
Can you give me an example of how NLP has evolved?
So NLP has evolved over time. We can see that in email and spam detection. It began with a very much in-your-face, have to configure it all up front, very rules-based. You would create a rule that said, oh, if the sender's from this domain, then reject it. If it's from this domain, accept it. Over time, it became more and more subtle and more effective. Modern emails, spam detection systems are very hidden. You can see email, of course, it's been put in the spam folder or not, but you don't even think usually about whether it goes somewhere other than flagging the occasional mistake. And that's because it's statistically driven. So a company like Google can look at the millions and millions of users of Gmail and see which emails they are flagging as spam and build statistical models that learn very, very quickly which email is likely spam, which is not. We see the same thing happening with the evolution of autocoding in healthcare, where initial autocoding systems were very manual, very rules-driven, required a lot of attention from the coders. Over time, we're seeing more and more automation and more background work. We still have a long ways to go.
Can you tell me a little bit about what this means for healthcare?
So what it means for healthcare is that as the technology gets better, we can return more and more to clinicians using language to speak with other clinicians. We have gone on this exercise of trying to get clinicians to talk to computers. And turning physicians into coders and all the other issues that, of course, generate a lot of concern and conflict because people want to be talking to each other. The fundamental purpose of a clinical note is for a human to talk to a human. And when we turn it into a human talk to a computer, we degrade the quality of communication. Natural language processing holds the promise of humans being able to talk to humans, but the computers following the human language and then getting the benefit of all the analytics and reporting and everything else that you can do with the powerful EHR and other recording technologies without having to force humans to talk to computers in a coding language.
What are the important components of an NLP system?
So a natural language processing system is made up of lots of pieces, and you've got, of course, a portion of the system that's thinking about language, and a lot of it is the same stuff we learned back in grade school. Diagramming sentences, when is a word a negation, telling whether a word's an adjective or an adverb. All of these are separate components inside of an NLP engine. A second important piece of an NLP engine is a dictionary. So if you don't have a dictionary, you don't know what the text means. You have to have something to refer to. You have to know that a dog is a canine to be able to do the kind of reasoning you're going to do. So you have to have some definitional logic there. You also need a lot of expertise in the actual final product. So if you're using NLP for auto-coding, you need to have a lot of coding knowledge and expertise to apply the coding rules from the clinical concepts to the final output. So there's really three major components. You've got the language processing piece, the dictionary, and then the mapping, the semantic processing that goes from clinical concepts to codes, documentation improvement queries, to whatever your target is.
What are the important things to consider when evaluating an NLP system?
So there's a great quote I like from one of the top textbooks in natural language processing, which goes, this is from Jarofsky and Martin, to evaluate a language model, you need to embed it within an application and evaluate the total application performance. Just like with email spam detection, we don't pick whether we're going to use Yahoo Mail or Gmail based on the vendor saying our spam detection is 97.3% accurate and built on top of rules. Instead, we use it and we assess how it performs in our overall workflow. Are we getting a lot of spam or are we not? And for an auto-coding system, or for a documentation improvement system that's using NLP, the question is, are my clinicians still focused on providing care instead of coding? Am I getting high productivity out of my coding staff and documentation improvement staff? And am I maintaining my reimbursement level? Am I getting the reimbursements I'm entitled to? That's the overall application, that's the purpose. And there's a lot of complexity and frankly a lot of fear, uncertainty, and doubt that can be cast in the complex technology of evaluating a natural language processing system. But pulling it back up to the level that we all understand as users of the reimbursement system and documentation management system is the best way to evaluate whether it's delivering value.
Okay. Well, I really appreciate you taking the time and letting us know about this. Thank you. This is Amy Monaghan with EHR TV with Dr. Richard Wolniewicz from 3M. Thank you.